In this lesson, we're going to answer the question, how can I combine like terms to simplify expressions? I'll be showing you 3 examples, and you can take 3 column notes with each one of these examples and showing you how to simplify them by combining like terms and using some other properties with adding and subtracting integers along with the distributive property to simplify them. Let's start off here with this first problem. You have n minus 10 plus 9 minus 3. So when I look at this, I need to identify what my like terms are, and you can see that my like terms in this expression are n's, 9n and n, and then I have 10 and 3. And let me underline those in blue, so we see 10 and 3 are kind of the same. So I know I can combine the 10 and the 3, and I know I can combine the 9 and the n. The tricky part here is also understand that I have subtraction, and when I got to think back to my adding integer rules, and I know that whenever I'm subtracting, it's really like adding a negative. So it's a good idea to rewrite this expression, n plus negative 10 plus 9n plus negative 3. The reason you want to rewrite this like this is because now that I'm adding, I can use the associative property or the commutative property, both of which basically say I can add in any order I want. So now I can change the order around however I want. What I'm going to do is I'm going to add the negative 10 and the negative 3 together. And over here to the side, I'm going to work that one out. Negative 10 plus negative 3 is going to be 13, and that'll be negative because both of those are negative. So it'll be negative 13, and it's going to be plus, and then I can add in my n and my 9n. So n and 9n would be just like 1. This is a positive 1 and a positive 9, so it's just going to end up being 10n. So it becomes 10n plus negative 13. Now this can obviously then you can kind of work backwards and say, well, if I'm adding a negative, it's the same as subtracting. So you can change this to 10n minus 13. And that's how you would simplify that expression, by combining your like terms. In this next example, we're looking at negative 2n minus 9 minus 10n. In this case, if you were looking to simplify this, you might look at like the order operation, see these parentheses, and say, oh, I'm supposed to do this first, but in here you don't have any like terms. What you have is you have negative 2n and you have a 10n, and then over here you have a 9, and it can't be simplified. But what you need to realize is that this minus sign is saying minus this whole quantity here, minus this whole thing, which really means that you would be basically adding. So I would be doing negative 2n, adding, and then you want to do negative, and you're really basically saying negative 1 times 9 minus 10n. And now in this case again, you can do 9 minus 10n. You can write that as 9 plus negative 10n, and that's all times a negative 1 being added to negative 2n. There we're adding, and when we're adding, we can rearrange the terms. So the first thing you have to do, though, is you have to distribute this negative 1 to the 9 and the 10n. So the negative 1 times 9 is just going to be negative 9 plus negative 1 times 10 is actually negative times negative, so that's positive 10n plus negative 2n. So now I've gotten rid of my parentheses, and I can now go back and look at my like terms and say the negative 9 is going to sit by itself. So I can actually just end this by saying negative 9 is going to be the end, plus, and then negative 2n and 10n. Well, when I add negative 2n plus 10n, you can kind of ignore the n's and notice I'm going to have an n there. And then you can say negative 2 plus 10. Well, those are two different signs, so I'm really going to subtract them. 10 minus 2 is 8. So the answer is going to be 8n. And when I go back and look at the sign, the negative sign for the 2, this is actually a lower absolute value than the 10. So the 10 and a higher absolute value, its sign is positive. So I say positive 8n. So my answer becomes 8n plus negative 9, which can be rewritten as 8n minus 9. All right, this is problem 3. This is the most challenging one we have. We have a negative 7 times n plus 3, and then we have minus 8 times 1 plus 8n. So the first thing I would do here is I would leave the negative 7 alone, times n plus 3, and then I would add and change this to negative 8 times 1 plus 8n. Now we can distribute the negative 7 and the negative 8 through their respective parts. So we can do a negative 7 times n, negative 7 times a positive 3. All the signs are addition now. Negative 7 times n is going to be negative 7n. Negative 7 times positive 3 is going to be negative 21. Plus negative 8 times 1 is going to be negative 8. I'm going to put parentheses here to indicate that I'm adding negatives. Negative 8 times positive 8n is going to be negative 64n. Now again, I can look at my like terms, and I see that I have n's and n's, negative 64 and negative 7. Adding two negatives is really just adding them, so I'm really just adding 64 plus 7. It'll end with n. 64 plus 7 is going to be 71n, and because they were both negative, it'll be negative 71n. And then it says my other like terms are negative 21 and negative 8. So again, I'm adding two negatives, so I just add them normally. 21 and 8 is 29, and because they're both negative, I end up with a negative 29. So negative 71n plus negative 29, which then can be simplified to negative 71n minus 29. So in this video, I showed you how can I combine like terms to simplify expressions, along with including some review of the distributive property and how to add and subtract integers.